Welcome to our podcast, everyone. Today we'll explore the fascinating world of evaluating LLM-based agents, those autonomous, interactive powerhouses that use large language models to plan, use tools, and juggle memory in real time. I'm excited to have 5 experts with us to dive into both the strategic business implications and the deep technical details.
Thanks for the invite. As a business leader, I've been watching these LLM-based agents reshape the enterprise landscape. It's like we suddenly have employees who can read thousands of documents in seconds, except they never take a coffee break. But of course, the big question is, how do we evaluate them effectively?
Right? And I'll just jump in here. My perspective is a little contrarian. We're so focused on maximizing performance that we often forget cost efficiency. I mean, sure, a hyper-tuned LLM agent might solve fascinating tasks, but if it costs a fortune in API calls, that's a serious business risk. The 80-20 rule definitely applies. We often get 80% of the value at 20% of the cost if we know how to measure and optimize well.
Absolutely, though from a technical standpoint, measuring that 80-20 is tricky because we don't just look at final outputs. There's this entire multi-step action sequence. Planning, tool calls, memory checks. Evaluations like Mint or PlanBench specifically dissect how well an agent can handle long-horizon tasks. And if each step is subpar, you end up with, well, a subpar solution overall.
Yeah, building on that, comprehensive frameworks track each intermediate step. Langsmith, for instance, can log every function call and let you do stepwise analysis. That's important because an agent might do 10 steps perfectly and bungle the 11th. Without a granular approach, you'd never see the exact point of failure.
That's so true. We once had a finance client letting a sales support agent handle hundreds of daily customer messages. After we integrated these robust evaluation tools, we discovered the agent was misclassifying 15% of inquiries. That's unacceptable in a revenue-generating channel. So we had to fine-tune it, focusing on each action's success rate rather than just overall pass-fail performance.
Wow, that's a real-world example that hits home. Expert 1, from a strategic angle, how do you see these thorough evaluation frameworks affecting broader adoption across different industries?
Well, it's crucial. Businesses don't adopt technology blindly. They'll ask, what's the ROI? Is it safe? Is it stable? Having benchmarks such as AgentBench or Gaia helps reassure people that yes, these agents can be measured like any other investment. When you can show consistent success rates plus reasonable operating costs, the boardroom lights up with interest.
I love the boardroom analogy. The challenge, though, is that the environment changes. Live websites evolve, new APIs appear, domain knowledge expands. So the benchmarks themselves must stay dynamic. Like BFCL going from one-step function calls to multi-turn, multi-tool tasks. As Einstein said, life is like riding a bicycle. To keep your balance, you must keep moving. The same is true for agent evaluation.
Indeed. And that real-time approach is also where specialized environments, or gym-like frameworks, come into play. They simulate the complexities of operating systems, real browsers, like OS World or Browser Gym, so you can see how well your agent really reacts to unexpected shifts.
Another big angle we can't ignore, memory. Let's talk about that. Many LLM agents have short windows of context. If an agent can't remember crucial details from the first conversation turn, we risk repeating fields or providing mismatched answers. Benchmarks like StreamBench or LTM benchmark measure how the agent performs over long contexts, verifying if it can pick relevant info from prior interactions accurately.
Right, and it goes beyond just retrieving data from memory. It's about self-reflection, too. If the agent receives feedback mid-task, can it adapt? Some new benchmarks like LLM-based grade an agent on how well it corrects its own reasoning. Think of it as a digital Sherlock Holmes, checking its conclusions for errors. If it can't do that, you may end up with a half-baked solution.
Half-baked solutions. Nobody wants that. I'm curious about a deeper technical angle. How are we ensuring that an agent's multi-step reasoning is robust without bloating the inference costs?
One approach is dynamic planning. Agents like React or frameworks like Karma store partial states, so they only expand the conversation or the computational steps when necessary. It's kind of like rebuilding an engine while you're driving the car, but done so efficiently that your fuel consumption, here meaning token usage, doesn't skyrocket. We measure these expansions with specialized metrics so you can identify wasted steps.
Also, you can incorporate retrieval modules that keep the LLM from reprocessing massive amounts of text each time. If it's already stored some high-level summaries, it can skip rereading them. Tools like memory compression or indexing are crucial. Then you see how the agent stands up in tasks like multi-document Q&A with narrative or scientific data, tested in benchmarks such as QMSum or Science World. Expert 3 and Expert 4, are you sure you didn't invent all these complexities just to confuse us? Joking aside, that's exactly why a cost metric is super critical. If an agent uses 50 tool calls to get the same result as a competitor who only needs 10, guess who the CFO is going to favor?
Couldn't agree more. For instance, in retail, we worked with a chatbot that used a meandering approach to confirm shipping details. Evaluations revealed an average of 8 calls to accomplish a 1-call task. Trimming that down to a direct approach cut operational costs by 25%. That's the kind of tangible business benefit that gets my ear.
Absolutely, and safety metrics are next in line. We see a big gap in tests for adversarial scenarios or compliance. Some advanced frameworks are starting to integrate policy checks, but it's still early days. For a healthcare or legal advisor agent, that's huge. Nobody wants GDPR or HIPAA violations.
Let's zoom out for a moment. Are we missing anything big in this swirl of excitement over LLM-based agent evaluation?
I suspect social implications. Everyone's focused on efficiency, but we might be ignoring the broader social or ethical bottlenecks. If your agent is great at planning but occasionally spouts misinformation, that can be disastrous. Future benchmarks will hopefully incorporate more real business constraints, like brand safety or regulatory compliance.
Couldn't agree more. People want confidence that these AI coworkers won't accidentally leak proprietary info or violate data privacy. Tools like Patronus AI attempt partial solutions, but the field is wide open for safe, scalable, and cost-effective agent systems.
That's an excellent wrap-up point. We've covered a ton of ground: planning, memory, function calling, cost, safety, and compliance. It sounds like the next steps are all about refining these dynamic, fine-grained benchmarks to stay one step ahead of ever-advancing LLM agents.
Precisely. And as these methods mature, I see more industries jumping aboard. Because as complicated as the technology is, once companies see the evaluations that show a stable ROI, better customer engagement, and manageable costs, it becomes a no-brainer.
Absolutely, and hopefully we'll see some more standardization soon. When every developer in business can point to a recognized benchmark suite, like when you buy a phone and check its battery tests, adoption will skyrocket.
Love that analogy, Expert 5. Okay, we're right at the edge of our time. Thank you all for bringing your insights and your healthy sense of humor to this discussion. It's been enlightening. Let's all keep an eye on these evolving benchmarks. And to our audience, thanks for tuning in. See you next time. And we are back for part 2 of our deep dive on evaluating LLM-based agents. I'm excited because now we're going to get even more technical, down to how you actually implement these evaluations in real-world scenarios, plus some concrete business applications. So let's jump in.
Indeed. From a business perspective, once we see that these agent evaluations can be implemented reliably, procurement and implementation teams become a lot more confident. So I'd love to hear the nuts and bolts from our technical experts first. How do we actually set up these multi-step task evaluations in practice?
Well, the approach typically starts with constructing or selecting a proper gym-like environment, something like Browser Gym or ML Gym, where an agent can freely interact with a simulated or sandbox environment. Then we define tasks in that environment, which might be web navigation, code debugging, or database management. The agent performs sequences of actions, and at each step, we log inputs, outputs, and especially tool calls.
Right, and to measure how well the agent is doing at each step, we typically rely on structured checks. For example, if the agent is calling an API, we can validate whether the parameters match expectations. This is where concept drift or dynamic liveness checks come in. If you're using BFCL or a tool-augmented evaluation framework, you might see how the agent adapts to new parameters introduced mid-task, like if the API schema changes, or if the user changes their request.
And you can store these logs in something like Langsmith or Google Vertex AI's evaluation service. That way you can not only see final success or failure, but also measure partial completion, stepwise accuracy, and how often the agent needed to correct itself. We even parse the system's memory usage or how many tokens get burned up during each call.
Exactly. Then you introduce a replay mechanism to systematically rerun the same scenario after changes, like a new agent prompt or a small tweak in the LLM. Seeing the difference in partial or end-to-end success rates is super revealing. Honestly, it's like running user acceptance tests, but for a giant AI, complete with logs for every micro-decision.
It sounds a bit reminiscent of how software testing frameworks do regression testing. Would you say that's a fair analogy?
Very fair, though maybe we need to coin a new name. Agent regression testing. But yes, it's the same principle of running multiple tests repeatedly under controlled conditions to isolate what changed and why.
That's also how we handle deeper metrics, like cost efficiency. If one agent version needs 35 calls to an external code execution tool, while the next iteration only needs 10, that's a major difference in both runtime and expense. Having stepwise logs is the only way to see that shift in real time.
Let me add a nuance. You also measure action advancement at each step, which basically checks if the agent's action leads it closer to the desired goal. Some frameworks explicitly record a binary measure at every turn. Did we progress, or are we spinning in circles? It's crucial for diagnosing repeated triggers or stuck loops.
Now, to pivot to business uses, these discrete metrics really matter. For instance, in large-scale customer support, we had a project with an outsourced contact center. Their agent typically asked the same question 4 times in different wording. Completely naive approach. After implementing an agent evaluation framework, we discovered that just shifting the agent's memory indexing reduced the repeated queries from 4 to 1. And that single improvement not only boosted customer satisfaction, but also saved them a tidy sum in overhead.
That's huge. And you also see it in supply chain management, where an LLM-based agent reorders inventory. If it calls the shipping API multiple times unnecessarily, you're incurring needless cost. Tracking that in a tool-use benchmark like Tool Sandbox can isolate the wasteful calls. Once fixed, the cost savings are instantly noticeable.
Building on that, there's a scientific research application I worked on. We used a multi-step evaluation from the Science Agent Bench framework. The agent first read multiple research papers, summarized them using a summarization tool, then proposed potential experiment designs. One misstep in referencing older papers meant running unnecessary lab tests. After we introduced a reflection mechanism, the agent cut that mistake rate by 30%. It saved weeks of lab time.
So from the strategic lens, imagine a biotech company jumping on that. Efficiency and R&D pipeline acceleration are direct competitive advantages. It tells me businesses that adopt robust agent evaluation, complete with cost, memory, and reflection metrics, gain more than just fancy AI. They gain tangible ROI and time-to-market benefits.
Right, and especially in regulated industries. If you have a framework measuring compliance or policy adherence at each step, you don't have to wait until the final answer to see if the agent went off limits or leaked sensitive info. Early detection is critical. Think of it like pilot warnings before the plane goes dangerously off course. Just don't let the agent try to land the plane by itself, yet. But yeah, that analogy fits. A real-time feedback loop is safer than a single post-flight analysis.
That's a great analogy, though it makes me a little nervous about the concept of the agent controlling a plane. Let's do a deeper technical dive on memory. We've touched on it lightly, but how are we implementing memory systems that scale, especially with context windows still limited?
There's a common pattern known as short-term and long-term memory separation. The agent maintains a short-term buffer for immediate interactions, like the last few user instructions or the last tool call results, and a separate memory data store, say a vector database, for longer-term reference. The long-term memory holds condensed semantic embeddings of earlier episodes. Then the agent can recall them with a retrieval step when relevant.
Precisely. And benchmarks like StreamBench or LTM benchmark test whether the agent can retrieve from that long-term memory effectively. The agent might read a complex user manual in the first session. Then a day later, the user references a small detail in the manual. If the agent doesn't retrieve it accurately, it fails the step. It's analogous to pop quizzes on old knowledge.
Implementation-wise, it often looks like a separate retrieval function call in your agent's code. Something like retrieve relevant past info, query. The environment tests if the agent can figure out when to call that function. A well-tuned agent might generate an internal reflection message, like, wait, we need that user manual snippet from 2 days ago, then do the retrieval. Otherwise, it tries to wing it, which typically leads to errors.
And we're seeing the same pattern for self-reflection tasks. Benchmarks like LLM-based track whether the agent corrects itself mid-flow. Developers can code reflection triggers, maybe after a tool call fails or user feedback arrives. Then, the agent spawns a sub-process to check its logic. If it does that effectively, you see better final results.
That's so intriguing. So you can code your own heuristics around when to reflect or retrieve memory, but the agent's also free to request that operation itself. It's like I don't have to wait for the boss to ask me to review the plan. I can be proactive.
Exactly, and it changes the game because the agent can become quasi-autonomous in refining solutions. Another business case, a retail QA agent that corrects itself if it senses it's giving inconsistent shipping info. Our client integrated this reflection approach and drastically cut inbound support escalations because the agent caught its own contradictions.
From a leadership perspective, that's the golden trifecta: minimal cost, minimal errors, and minimal user frustration. And that's only possible when we have the right metrics in these advanced evaluation frameworks, measuring everything from reflection success rate to memory retrieval accuracy.
Also, the new wave of tasks in multi-domain benchmarks, like CRM Arena or the Agent Company, demands these robust memory and reflection patterns. Because the agent might start with marketing tasks, then pivot to product data, then go into analytics. If it can't seamlessly carry context across these domains, we see major stumbles.
True. And I see the next frontier of agent evaluation focusing on advanced safety checks and compliance. For instance, a fine-grained approach might track exactly which policies are referenced at each step. If the agent deviates from an internal compliance rule, it logs it. That's the missing piece right now, especially for finance or healthcare applications.
I have to say, there's a risk we end up with analysis paralysis, where we measure 1 million micrometrics but don't unify them. But maybe that's the evolution. We gather all these data points, then funnel them into something like a single, multidimensional agent score, like the AI world's version of a credit rating.
A single agent rating, like a FICO score for AI. That would certainly simplify board presentations. So before we close, I'd love each of you to give one final, unexpected insight or tip about implementing these evaluation frameworks.
I'll jump in first. Don't underestimate synthetic data generation. Tools like API Gen let you produce realistic tests for function calling. That can expand your coverage drastically without needing massive manual labeling. We used it in a project and discovered error modes in date formatting that we'd never even considered.
My tip: set up small, fully automated tests to run daily builds. Even if you only fix some prompts, run the entire agent suite on a nightly schedule. Issues creep in slowly, so capturing them early is essential.
I'd say keep an eye on cross-task evaluations. We often see an agent do well in a single domain, like code generation, but falter in a conversation domain. A generalist agent is only as strong as its weakest domain link. Benchmarks like AgentBench or Gaia help unify these perspectives.
Mine is about cost trade-offs. Never ignore those. A state-of-the-art LLM might outperform a smaller one by 3%, but cost 10 times more in inference. Evaluate that difference with actual usage logs. Sometimes, good enough is your real hero.
And from the business vantage, measure trust. That might sound fuzzy, but if your employees or customers don't trust the agent's output, adoption fails. Maybe use LLM-based judge systems or short user surveys to track trust levels. Prove reliability with data, and everything else falls into place.
That is a fantastic set of tips, each with a very practical angle. I love that we ended on this synergy between technical rigors and strategic business ROI. Thank you all for such an in-depth part 2. I think we've effectively tackled both the how and the why of agent evaluation. Until next time, keep reflecting, keep measuring, but don't blow the budget on extra tool calls, right? Take care.